In last video, we have learned about three-phase diagram. In three-phase diagram, it is conventional to write volume on the left-hand side and the mass on right-hand side. The total volume of given soil mass is represented as V. It is equal to the sum of the volume of soil, volume of water, and volume of air. The volume of voids is equal to the sum of volume of air and volume of water. The total mass of a soil mass is represented as m. The mass of air is very small and is neglected. Therefore, the total mass of soil is equal to mass of solid and mass of water. Now, let's study volumetric relation between these three phases. The first volumetric relation is void ratio. Void ratio is defined as the ratio of volume of voids to the volume of a solid. The void ratio is expressed as decimal numbers such as 0.4, 0.5, etc. For example, if void ratio of given soil is 0.4, it means the volume of voids in soil mass is 40% of the volume of solid. Hence, the total volume of soil mass will be 1.4 Vs in terms of volume of solid. Now, let's see some importance points related to void ratio which should be noted. The voids in the soil mass will never be zero, as soil always contains air voids. So according to formula, void ratio cannot be zero and will be always zero. However, if volume of voids is equal to volume of solids, the value of void ratio will be equal to 1. And if volume of void is more than volume of solid, the value of void ratio will be more than 1. And if volume of voids is less than volume of solid, the value of void ratio will be less than 1, but more than 0. Second volumetric relation is porosity. The porosity is defined as the ratio of volume of voids to the total volume of soil mass. It is expressed as percentage, such as 40%, 50%, etc. For example, if porosity of given soil is 40%, its mean volume of voids in soil mass is 40% of total volume of soil. It also means remaining 60% will be volume of solid. Now, let's see some importance points related to porosity which should be noted. The porosity cannot be zero because volume of voids in soil mass cannot be zero. Hence, porosity will be always more than zero. The porosity of any soil mass will be always less than 1 because the volume of voids in the soil mass cannot be more than total volume of soil. So, in general, we can say that the value of porosity will be always more than 0, but less than 1. There is interrelationship between void ratio and porosity, that is, N is equal to E by 1 plus C, and E is equal to N by 1 minus N. Third volumetric relation is degree of saturation and air content. The degree of saturation is defined as the ratio of volume of water to the total volume of voids. And air content is defined as the ratio of volume of air to the total volume of voids. Both degree of saturation and air content are expressed as percentage, such as 40%, 50%, etc. For example, if degree of saturation of given soil is 60%, it means volume of water in soil mass is 60% of total volume of voids. It also means remaining 40% of volume of voids will be volume of air. So, for the same soil, air content will be 40% of total volume of voids, and remaining 60% of volume of voids will be volume of water. From these two definitions, we can conclude that for the same soil, the sum of degree of saturation and air content will be always 1. Hence, the relation between degree of saturation and air content will be given by this formula. Now, let's see some importance points related to degree of saturation and air content which should be noted. In case of fully saturated soil, the volume of air will be 0, hence degree of saturation will be 100%, and the air content will be 0. In case of dry soil, the volume of water will be 0, hence degree of saturation will be 0, and the air content will be 100%. So, in general we can say that the values of degree of saturation and air content will be always between 0 to 1. The fourth volumetric relation is percentage air void. The percentage air void is defined as ratio of volume of air to the total volume of soil. Percentage air void are expressed as percentage such as 50%, 60%, etc. For example, if percentage air void of a given soil is 60%, its mean volume of air in soil mass is 60% of total volume of soil. Now, let's see some important points related to percentage air void which should be noted. In case of fully saturated soil, the volume of air will be 0, hence percentage air void will be also 0. In case of dry soil and partially saturated soil, the value of percentage air void will be between 0 to 1. Now let's see mass relation of soil mass, which is water content. The water content is defined as the ratio of mass of water to the mass of solid. It is expressed as percentage such as 30%, 50%, etc. For example, if water content of a given soil mass is 30%, its mean mass of water in the soil mass is 30% of the mass of solid. As previously, we have learned that the mass of air will be always 0. Hence, the total mass of will be 1.3 ms in terms of mass of solid. Now, let's see some important point related to water content which should be noted. For dry soil, mass of water will be 0, hence, value of water content will be also 0. For fully and partially saturated soil, value of water content will be more than 0. In addition, if mass of water is less than mass of solid, then value of water content will be less than 1. And if mass of water is more than mass of solid, then value of water content will be more than 1. For more video, subscribe the channel and press the bell icon so that you can get notification